If you want to get from here to there, you have to decide what bus to get. And these days, if you want to get from your computer CPU to just about anywhere else, you also have to decide what bus to get. Should it be the AT bus or the MCA bus or the EISA bus? Today, we take a look at the great PC bus wars and ask the question, what is a bus anyway? On this edition of the Computer Chronicles.
Computer Chronicles is made possible in part by McGraw-Hill, publishers of Byte magazine, and BIX, the Byte Information Exchange. In print and online, Byte and BIX serve computer professionals worldwide with detailed information on new hardware, software, and technologies.
Welcome to the Computer Chronicles. I'm Stewart Cheifet, and this is Gary Kildall. Gary, what I have here is a motherboard from an AST286 computer, an add-on board. This uses the standard AT bus. This is a motherboard from an IBM PS2, an add-on board. This uses the microchannel architecture bus. They both look very much the same to me. I want to ask you, what exactly is a bus, and why should it matter to me as the end user? Which bus is in my computer?
Well, it's a matter of standards, obviously. Just like in software, the operating system becomes a standard to write software to. You need some kind of a standard to communicate electrically between a motherboard and add-on boards and so forth. Physically, the bus is this definition of the pins that go, you see in the bottom, of course, of the board. Address lines, data lines, for example. This is a 16-bit bus. This is a 32-bit bus. So it defines about how much data you can move between memory and the central processing unit, for example. Well, of course, the AT bus has been around for years, and there have been lots and lots of optional boards that independent vendors have produced for it, fax boards, modem boards, graphics boards, things of that sort. The microchannel architecture, of course, hasn't been around as long, and the installed base of this type machine isn't as large, and so that's going to grow over time, but there's not as many options.
Gary, today we'll take a look at IBM's microchannel architecture bus. We'll look at the standard AT bus. We'll try to find out what this new EISA bus is all about. And we'll take a look at a computer that claims to be bus switchable. Now, how much confusion is being created in the marketplace by these bus wars? We're going to try to find out now by visiting a computer retailer and a Fortune 500 customer.
The difficult task of choosing which computer to buy has been made even more difficult recently, thanks to the introduction of new bus architectures. Not surprisingly, IBM's new microchannel, the rebellious clone makers, and Apple's new bus Macintosh are making it tough to decide for a lot of different buyers.
In this industry, when a product is introduced and a continuation of the old product is not made available, then it causes some problems because there's not enough time to change over to a newer product.
Among larger companies, the decision to change or not to change is based in part on the equipment already in-house and whether there's a genuine and immediate need to upgrade the hardware.
It's too much to jump financially right now to even consider that. I mean, I've got to depreciate some of this stuff. This equipment that you see around me is all less than 2 years old. So, you know, I don't see us moving on real quick. It just didn't make financial sense.
While most PC buyers wouldn't object to the improvements offered by new bus designs, such as smaller size and multitasking, some users have lingering concerns about some potential drawbacks.
One of the problems with getting into multitasking and that kind of use is that it takes a tremendous amount of learning time. That's a big investment.
Historically, the latest competition in the PC market is nothing new to retailers and may in fact be settled by none other than computer users.
Joining us in the studio now is Bob Kutnick, Director of Strategic Projects at AST Research, and next to Bob is Richard Archuleta, Research and Development Section Manager with Hewlett-Packard. Gary?
Stuart, probably worthwhile getting a little background here before we get too far into this. What we're basically dealing with is 3 different competing bus structures. The standard AT bus, which you find in your normal PC, of course, and that has an evolution to this point. The micro-channel architecture, the new IBM bus, and then I guess EISA. And Bob, tell us what EISA is. What does it stand for?
EISA stands for Enhanced Industry Standard Architecture, and what it is it's a natural evolution of the AT bus into the 32-bit realm. So for example, we went from a PC to an AT, now we've gone from an AT into EISA.
And now who's supporting this, EISA standard?
There are over 100 companies that have applied for the specification. There were 9 original companies that created it, and some of those companies are AST, Hewlett-Packard, Compaq, Zenith, Tandy, Wise.
Okay, and what is it about an AT bus that caused you to create a new, well, additional pins in the card and so forth?
Well, the kinds of things that you would like to add to it that would give the user extended benefit in the long run are bus arbitration, which would allow you to run multiple processors, as well as enhancing the DMA operations, allowing for more memory on the bus. The AT was limited to 16 megabytes and so on.
Okay. Bob, give us an example of what a piece of software would look like running under the AT bus with its current limits.
Okay, this is an existing AT bus, and we see if we open a window here, we're running a standard application. This is DBase, and we see how fast it's scrolling. If we now open up another window, which is Lotus 123, we see that this application dramatically slowed down. It's now scanning through, it's acting much slower, and if we open a third application, we see it even slows down more. What would happen in EISA is if you had multiple processors, each one of these tasks could be running on an independent processor, and in effect you wouldn't even notice a slowdown.
Okay, now doesn't the MCA bus attack the same problem?
The MCA bus is very similar, but I think we can see quite a difference here in the outlay of the card.
Well, show me, we've got them here. Show me.
We've actually got both cards here, and as we see, this is a standard AT card with an extra connector, and this sort of simulates what the AT with EISA type connector would be. First of all, we notice a tremendous size difference. This is an actual processor card designed to fit into an AT bus, and as we see, this card is very densely populated. For a person designing a card, especially an entrepreneur, it's very complex to design these because you have to design ASICs or application-specific integrated circuits in order to get down to this level of miniaturization. Whereas as we see, there are no ASICs on this card, just PALs, memory, and a 386 and a 387.
Are you carrying any baggage over from the AT bus into EISA? Some of the things you wouldn't like to have in a new standard?
There is some baggage, but basically speaking, EISA is a natural evolution. It's a 32-bit evolution of the 16-bit AT standard.
Rich, from HP's point of view, Hewlett-Packard's point of view, why have you gotten involved in the Gang of 9 and the EISA standard?
Oh, we did a lot of investigation into microchannel since its introduction, and we had a lot of conversations with our customer base. And one of the things they told us was that they had a problem. They liked the natural, all the extensions that microchannel offered them, the enhanced arbitration, the ability to add multiple processors, the automatic configuration of cards, the switchless settings. It's all great advantages of microchannel over the AT. But they had a problem in transitioning from the current base of machines that they have over to making a dramatic change to the microchannel products. And the independent hardware vendors that we talked with had the problem that Bob just described, which is, trying to fit all the logic onto the size of a card that microchannel is currently defined to be. So what we've been working on for a while, what all the consortium of companies has been doing, is trying to see if we could find a way to naturally evolve the AT bus and pick up all of the features that are advantages of microchannel. And I think we've done that with the EISA.
Now, in terms of timing, how long is it going to be to market for these things? When are we going to see these things?
I think near the end of next year, we'll see EISA products.
Yeah.
Is that a problem, Bob? That, I mean, we're talking about yet this other standard, and it really doesn't exist like so many other things we hear about.
I don't think so, because number one, EISA is really a statement of direction. It says that if you have an existing base of machines, i.e. the AT, that it's now expandable into EISA. So what we found is in talking to our customer base, they see it as insurance. They see it as though they can buy AT machines today and know that they can be extended tomorrow by adding the architecture and still being able to use currently existing AT cards.
Is this a kind of technology battle really among these buses, or is it just a marketing battle?
This is actually a natural evolution of an extension to the AT bus. And again, if we came back to this card, we'd see the PC started off with just this connector. Right. The AT extended to just this connector, and now by adding one other connector to the board, it's the natural evolution. It carries it from 8 bits to 16 to 32, and with the added features.
With the advantage that you get to use the old boards that have been designed.
Yes, every old board will function in the bus.
Right. Bob, Rich, thank you very much. The battle of buses is not only between MCA, AT, and EISA, but there's also something called New Bus that Apple uses on the Mac II. Wendy Woods takes a look at the New Bus architecture.
When Apple Computer went shopping for a new bus, engineers decided to go with a model that already had a few miles on it. They chose New Bus, an architecture invented by Texas Instruments and already in use by over a dozen other computer companies. New Bus, the architecture of the Macintosh II line, represents several technical breakthroughs.
New Bus, for one thing, is a very fast bus. It can support, because of its origin in the AI community at MIT, it was designed to support a tremendous amount of data movement between individual cards or between the card and the CPU itself. The other factors that really came into play was that it was able to support a wide variety of card architectures. From the point of view of the developer, it's a large board area. It's very inexpensive for someone to develop cards for, and the result was going to be that we would have a very large number and very wide range of cards for the Macintosh II. That was also important.
Further, unlike some bus structures, this one doesn't require a specific card in a specific slot. All New Bus cards work with all other New Bus cards, and all are interchangeable in all of the slots. Apple believes the New Bus architecture has staying power. It has a track record. In fact, some 60 firms are expected to adopt New Bus for their peripheral cards and computers. And developers are giving it rave reviews. For the Computer Chronicles, I'm Wendy Woods.
With us in the studio now is Chet Heath. Chet is Senior Engineer for Hardware Architecture at IBM, and Gary, Chet is commonly credited with being the father of the MCA bus.
Okay. Is that correct?
Well, I think more exactly, I'm the oldest living survivor of microchannel architecture, and there was a cast of thousands.
Chet, when you were designing a new architecture, new bus architecture, why didn't you just extend the existing AT bus?
Well, I think the problem goes back to the AT cards, that in order to extend the capabilities for multitasking, to support faster I/O and to support that all at the same time, we needed to be able to get the cards to be less dependent upon the processor. There were no alternative services in the AT bus. When we looked at other problems like sharing of interrupts and automatic configuration, we saw a preponderance of problems that drove us toward a new solution.
Okay. Don't you have an example there of a bus you were playing with, experimenting with when you were trying to expand the AT bus?
We built an early prototype. This is a 110-pin connector of an extension of the AT in about 1984. We had running program option select in that. We had some experiments with EMC in that machine. We had initially some level-sensitive interrupts and also tried the edge-triggered interrupts at the same time. We had difficulty getting the AT cards to run in the same environment with advanced cards that would be more dependent upon DMA and less on the processor.
Now, Chet, is MCA, is that considered a proprietary architecture? In other words, can other manufacturers use that?
Well, I really don't understand the term proprietary. That, to me, that would mean that it's not available. Right. And it certainly is probably one of the best documented architectures around, and it's available for use by anyone. Okay.
Now, you have an example of how you used it, I guess, in a test machine here.
I think there are now, 550 cards that have been built for the microchannel, but very few of them use this particular feature here, which is the ability to support more than one processor in a system.
What's the open box here before you go on, Chet?
This is a Model 60 with a test tool built by Ernie Mandisi of Boca Raton that was built in 1986 to demonstrate to our satisfaction that the microchannel could support a number of processors. On this card we have an 8 megahertz 2-weight state processor, hardly something that would be that we would bring out today with 2 weight states. But as a test tool it was satisfactory, and we are operating on the screen in the top blue line here a dry stone benchmark fixed point arithmetic that is operating approximately 2,000 dry stones per second on the planar processor. Now, to simulate what would happen in a multitasking scenario, we can take that dry stone and run 2 of them at the same time, and you get approximately 1/2, the blue and the green,
the speed is dropping down.
1/2 of the number of dry stones per task, but you now have 2 tasks running. So the total number of dry stones is the same. Now, in this next scenario, we're bringing it back to prove that if you run the dry stone on one processor all at the same time, it's about the sum of the 2, approximately. There is some small overhead in this. Now, we're going to take the dry stone, load it in the planar processor, it runs as before, and also we've loaded in this pink line into the concurrent processor running down here in this large card. Now, we have approximately the same power that we had before, less some amount of
So the first application is running roughly at the same speed now.
Roughly at the same, and now the second application is running, and in essence the power is additive to some rough degree. The ability to run, this is one of about 15 concurrent processors that could be run in the microchannel, although as you can see there's a severe packaging problem, particularly where this thing was 2 years ago.
Can you pop up a third application in there?
Yeah, let's try that.
And what do
we
see
have
now?
the top processor now is divided into 2 tasks as before, so we're getting approximately 1/2 of its initial performance divided in 2 tasks, and then the second processor is operating a single task. This is to simulate that you really could have 2 different operating systems running on the different processors.
How many processors do you think you could put on the channel before you get blockage to memory, where you get memory access timing problems?
Well, the problem could exist in a single bus computer, but in a dual bus computer, particularly as each processor had its own local storage, pulling the majority of its instructions out of that processor, I believe we could achieve the 16. It would depend on how interactive the tasks were with each other and to the degree to which they use I/O.
Chet, as the guy who really designed this MCA bus, what are your reactions to the EISA and the criticism of MCA?
Well, I don't understand the criticism of MCA, but one thing I don't feel is really necessary there is to take and reproduce a concept that is fundamentally equivalent to the microchannel. If one understands that you really don't need the old cards, that they would hamper you in moving forward, that most of the functions have been reproduced on the planar of the PS2 systems, and there exist maybe 550 cards that reproduce all of the other card functions that are available, that if you can get away from that notion, then you have a base upon which people can work. Outside the people I've met in the last 2 years, there's a tremendous wealth of creativity and knowledge. And to see that reproducing a function that's basically already there, I believe is less productive than if we were to work together, building upon the base we have now. I believe some very exciting possibilities are out there that have not yet been tapped.
How soon do you think we'll see that? That's one of the other wraps. Nobody really understands it can get the benefit of MCA right now.
Well, the timing is such that many of these cards as concurrent processors are as complex as systems. By the last Convex, we saw some individuals who had taken the microchannel and had operating prototypes to show. I think by this Convex you may see that they have reduced the form factor and power of those cards such that they fit within the microchannel format. I've already seen some evidence of this in the trade press with I/O processors and smart file systems and also use of DMA. We have 5 times the DMA capability of the AT, and it's an inexpensive way of getting the power back to the processor.
Chet, thanks for joining us. Okay, if you're not sure what bus you want to put into your computer, in just a minute we'll take a look at a computer that is bus switchable, so stay with us. Joining us in the studio now is Michael Hoyle. Michael is product manager with Wells American, makers of a convertible bus computer called the CompuStar. And next to Mike is Win Roche, contributing editor with PC Magazine.
Win, we've seen 2 competing architectures here, the EISA and the MCA. What is your opinion about this battle?
Well, it's a hard battle to call because you're looking at 2 entirely different things. You're looking at something that's been around for about 2 years, and you're looking at something that's going to be a year and a half, maybe 2 years before you actually see. You can't really characterize a battle with something you don't know what it is.
Okay.
But my initial impression is we have something that's looking to the future, microchannel, that breaks with the past and buys you something that's going to be around for a while. And then you have EISA, which is tying you to the past. You're loading your system down with old cards that may not be good performers in the future.
Okay, well, give an example of that. What would hold you back in using, let's say, an AT extension like that?
Well, any of the old cards that you have in an AT are not going to have 32-bit performance. And to get 32-bit performance, you have to add new 32-bit cards into the computer. If you have to buy new 32-bit cards, why not buy a higher performance standard like the microchannel?
Yeah.
Mike, you've tried to come up with a sort of compromise here, I guess, in your CompuStar, and explain what the theory is behind this sort of bus switchable computer.
Well, the concept behind the CompuStar is that we're constantly in a state of transition in the industry. And it's significant to note that every 3 years we seem to change from 81 to 84 to 87. We went from 8 to 16 to 32-bit. And we're now in a situation where we're 1.5 years past the 87 mark, and we should see an 84, 86 or equivalent from Intel next year, which means we may transition yet again in another 1.5 years. The CompuStar concept is one that is convertible. Users can change between processors and even change between bus architectures as their needs dictate.
Okay, that's your CompuStar tower up here. Gary, if I can ask you to kind of rotate that and start to take it apart. I want you, Mike, to show us how you do all this stuff.
I've become a certified CompuStar disassembler here.
There you go.
Okay.
Okay.
We'll start with this side anyway. If I can.
Okay, Mike, you're on. How would you switch cards and boards?
Well, now we're into two chambers here. First is the drive chamber, and then the second is the electronics chamber, which is inside here. We'll remove that and let you see the electronics. Now, this is a processor module, which is interchangeable. We'll take this tool, remove this screw, like so, and we'll take the processor module out of the system. And this is an 8286 processor module. We could exchange that with a 386, 486, or what have you.
Okay.
Here we have a bus module adapter. We'll use that to change between different bus architectures as they evolve. As new technologies evolve, we intend to research their effectiveness and, if desired, implement them into the convertible process. This one happens to be a PS2 convertible bus. Here we have the actual backplane of the PS2. Notice that a bus structure includes mechanical and electrical connections. What we have done here is the back panel of the machine is actually interchangeable, so you can have different bus structures. This is the PS2. Here we have a primary bus structure, which is the industry standard AT bus. Okay. We have one more board in here, which is a standard I/O module, which performs all the normal I/O tasks, including video, that is found in most computer systems.
Now, do you think that this sort of hybrid approach is a proper way to go?
It seems to offer a better alternative than EISA might, because it doesn't restrict you to any architecture. And if you decide to go microchannel, it will take you to microchannel. Presumably, they'll let you go to EISA if you want to go that direction. So it may be the best of all possible worlds.
Is there confusion in the marketplace now, and is that a problem in this whole IBM compatible world? People don't know what to do because of this bus battle?
Some people are even saying that the bus battle is to create confusion in the marketplace. Talking to people, I've not determined that there is any confusion. I've found skepticism on the part of people toward EISA. Some people say they don't think it's for real, but that always occurs when there's a promise and it's not going to be delivered for 2 years. I can't call it until I see it, but right now we have a standard that's acceptable, a high-performance standard, and it seems like a good bet. If you're looking at MCA, and it seems like there's still a lot of life left in the ordinary AT bus as well for other applications. It seems like you might have two different directions to go. You have the AT bus for run-of-the-mill applications, and if you want high performance, you have microchannel. EISA may fit in the middle, or it may go toward the high end. We don't know until we see the machines.
Mike Wynn, thank you very much. That's our look at the bus wars. Hope you'll be with us again next week on the Computer Chronicles. In the Random Access file this week, IBM and Microsoft have begun shipping OS/2 version 1.1 with Presentation Manager, the new PS2 graphics interface. A Microsoft spokesman says despite some bad press, OS/2 development is moving along faster than the support MS-DOS received when it first came out. IBM and Microsoft have also announced a new promotion in which IBM will be bundling Microsoft Works and Microsoft Windows with hard drive PS2 Model 25s sold at universities or colleges. If you're willing to split for the PS2 Model 50Z or 70, IBM will also throw in Microsoft Word and Excel. Meanwhile, the saga of Lotus 123 version 3.0 continues. This time it's a shareholders' lawsuit against Lotus, claiming that Lotus management disseminated false and misleading information about the delivery problems with version 3.0. The shareholders' suit charges Lotus with securities fraud. The newest version of 123 is about a year behind schedule, and the delay in shipment has hurt the value of Lotus stock. Software sales in general continue to grow at a phenomenal rate. According to the Software Publishers Association, software sales for the first 3 quarters of this year were up 48%. MS-DOS software accounted for 77% of all software sales. Macintosh software, which ranked second in sales with 11% of the market, got the honors for the fastest growing segment of the software market. Next in market share were the Apple II and the Commodore 64. Steve Jobs was courting the education market again last week as he showed off the next computer at an educational computing conference in Washington. It was the first chance many college types had to actually see the new computer. Reaction was mixed. Some thought it was too expensive, some bemoaned the lack of color, but most all the spectators said they'd love to have one. Some of the comments suggested it was too pricey to compete with PCs or Macs and too limited to replace Sun or Apollo workstations. Desktop publishing has migrated from the boardroom to the classroom. The Learning Company has come out with the Children's Writing and Publishing Center, described as a full-feature desktop publisher for children 9 years old and up. The program features a WYSIWYG display, multiple fonts, automatic picture wraparound, a library of graphics, and a color printer support. The online service The Source has announced a new feature called RateGram. It allows users to check out certificate of deposit rates and money market fund returns from over 15,000 U.S. financial institutions. RateGram lists interest rates, annual yields, compounding frequency, and minimum investments. With HyperCard just a year old now, the HyperCard add-on market is starting to grow. MacroPack International has just come out with 101 scripts and buttons for HyperCard. It features 5 new kinds of buttons, new HyperCard utilities, an animation recorder, and other new HyperCard tools. Finally, VaporSoft Inc. has reissued its Nerd Perfect Vaporware just in time for the Christmas gift season. Nerd Perfect from VaporSoft comes complete with a confusing manual and no software. The gag package sells for $9.95. That's it for this week's Chronicles. We'll see you next time.
The Computer Chronicles is made possible in part by McGraw-Hill, publishers of Byte magazine, and Bix, the Byte Information Exchange. In print and online, Byte and Bix serve computer professionals worldwide with detailed information on new hardware, software, and technologies.
For a transcript of this week's Computer Chronicles, send $4 to PTV Publications, Post Office Box 701, Kent, Ohio 44240. Please indicate program date.